We're going to do a short intro today about sequences and series. We're going to start with a sequence. As you can kind of see by the definition, it's a function whose domain is the set of positive integers. You can kind of see by the subscript right here that it has, it tells you what term you're with. So this one right here is the first term of the sequence, this is the second, third, fourth, and so on. We're going to start with a finite sequence, which means it's a sequence that has an ending. It'll stop at a certain amount of terms. Later on, we'll get into infinite sequences. We're going to start with something real basic, the idea of writing the first 5 terms of the sequences. Given for the first one, a sub n equals 4n minus 7. So what we're going to do is we're going to go with the first term, so a sub 1. And what we're going to do is, you can see how it replaces the n right there. Every time we see an n, we replace it with the 1, and then just evaluate. So the first term in our sequence is 4 minus 7, which would be negative 3. I'm going to do that with the next one. 4 times 2 minus 7, 8 minus 7 is 1. And I'm going to keep going. So 12 minus 7 is 5. A sub 4 is 4 times 4 minus 7. So 16 minus 7 is 9. And then the fifth term would be 4 times 5, 20 minus 7, which is 13. When we go to list these out, we get negative 3, 1, 5, 9, and 13. And I just want to take a minute and note a couple things that we see. If you look at each one of those terms, they increase by 4. Some of you, this will seem very obvious, and that's because every time we increase the n, or the term number, we are basically adding 4 to it. And that's something we want to kind of keep note of as we get into actually writing the expressions for the sequences. We're going to do a couple more examples. They're going to get a little bit more complicated. A sub 1, a sub 2, a sub 3. And I'm just going to do the same thing. 2 times 1 over 1 plus 1. So 2 over 2, which is 1. And then I'm going to do 2 times 2 over 2 plus 1, which is 4 over 3. And then 2 times 3 times 3 plus 1. That's 6 over 4. I'm going to reduce that to 3 halves. And then a sub 4 equals 2 times 4 over 4 plus 1, 8 over 5. And last one, a sub 5 is 2 times 5 over 5 plus 1. So 10 over 6. So again, reduce it down to 5/3. If I'm going too fast to this, go ahead and pause it. Make sure you catch up. And what I am going to ask you to do is to pause it for a second and to actually do 3 and 4 by yourself, and then check your answer afterwards. So you can go ahead and pause and check your answers for these two, for the 5 terms that we get for each. I do want to point out a couple of things in number 4. This is going to kind of hopefully help us kind of write these sequences later on. And I'll backtrack to 3 as well in a second. But you notice that in number 4, we go negative, positive, negative, positive, negative. And the way that we can kind of get that pattern happening is because of this right here, this part, this negative 1 to the nth power. Because if it's to an odd power, like 1, it's going to end up being negative 1, and that just changes the sign. But if it's a positive, it's going to change that negative 1 to a positive 1, and again, not affecting anything that comes after that. From there, also, you can kind of just see when we're looking at these patterns, when we look at just the numerator, 1, 2, 3, 4, 5, that kind of gives us to that n. And looking at the n plus 1, or the least denominator, again, we see that increasing by 1, so that addition of 1 right there. But we know it's 1 more than the numerator, so adding that to that number. And again, going back a little bit to 3, we can see kind of the patterns, looking at the patterns of the numerators that's happening. We go 3, 9, 27, 81, 243. If we worked backwards on that, we should hopefully see that those are all multiples of 3 and coming up with 3 to the n. And then looking at the denominator, multiples of 4. So now we're going to start writing out a couple of expressions for the sequences that we're given. So what we want to try to see if there's a pattern. So think for a second, how do we go from the one before to the one after? And hopefully you'll see that we add 4 each time. Now, this should seem familiar from example number 1, right? So we talked about that, adding. And it didn't come from this part right here, but instead came from multiplying the actual sequence or the term number. So what we're going to do with that one is we'll start with a sub n, saying any generic term is 4 times n. Now, let's think about this. If the first term is 1, 4 times 1, that would be 4. Well, that's clearly not the case. So how do I get to 3? I would subtract 1. So let's make sure that makes sense. If I put a 1 in here, 4 times 1 minus 1, that equals 3. That checks out. 4 times 2 minus 1, that's 8 minus 1, that gives us 7. So far, it's looking pretty good. 12 minus 1 gives us 11. So we're going to use that as our generic sequence, or expression for our sequence. Going to number 6, hopefully we see the positive, negative happening. And so we're going to start that by doing a sub n equals negative 1 to the n power. Now there's one thing I'll point out. Notice that in number 4, our first number is negative right here. Because if it was negative 1 to the first, that equals negative 1. That would imply that that would be negative 1. Well, we want it to be positive. So what we're going to do is we'll just take that n and we'll minus 1. Because 1 minus 1 is 0. Anything to the 0 power is 1, and it brings it back to a neutral number. Then let's take a look at the rest of the terms. So let's start with the numerator. We have 1, 2, 4, 8. Those are all multiples of 2. So we'll do 2 to the n. We'll start there. But again, if I do 2 to the first, that's 2. That's not quite there. But it is here. So what I'm going to do is I'm going to make this minus 1, because that kind of brings it to this term. So instead of being at term 1, this moves it to term 2. 2 minus 1 is 1. 2 to the first power is 2. Now this is the third term. Let's see here. Third term's right here. So if I do 3 minus 1, that's 2. 2 squared is 4. So that kind of checks out that pattern. So let's go to the denominator. The denominator, 3, 9, 27. Hopefully we see that pattern. It's going to be 3 to the n power. We're going to finish with these last 2 questions, 7 and 8, and we're going to save the rest for Monday's class. It tells us to write the first 5 terms of the sequence defined recursively. So we just want the first 5 terms. Okay, we're only given the first one though, which in this case is 15. But then we're kind of given this part right here, where it says a sub k plus 1 equals a sub k plus 3. So if we think about this, we have a sub 1, a sub 2. Eventually, we'll get a sub k, and then a sub k plus 1, a sub k plus 2. So we're adding. So eventually, we start adding those down the line. So what this is saying is to get this one, I have to go backwards 1 and add 3. So to get from here to here, we add 3 units. So let's think about that. If I am constantly adding 3 units, the first term should be 15, the second term should be 18, the third term should be 21, the fourth, 24, and the fifth term, 27. Now, that's kind of how we can draw to that conclusion if we want to actually see it with numbers. If I'm looking for the second term in this, so if I'm looking at a sub 2, and I plug 1 in for right here, so a sub 1 plus 1 equals a sub 1 plus 3. Well, a sub 1 is given as 15. I add 3, that gives me 18. If I did this for the next one, I take 2 for k, that gives me a sub 2 plus 3. A sub 2 is 18 plus 3, that gives us 21. And the last one we're going to look at is number 8. And again, let's kind of look at what this is saying. It's saying a sub k equals a sub k minus 2 plus a sub k minus 1. So let's think about the sequence for a second. Here's a sub k, and then we get a sub k plus 1. But going the other direction, I get a sub k minus 1. But before that, it would be a sub k minus 2. So what this is saying is that a sub k can be found by adding the previous two together. So if I know a sub 0 equals 1 and a sub 1 equals 3, then a sub 2 comes from the previous 2, which is 4. Then what we're going to do is we're going to take those two new ones, and to get a sub 3, I add those together to get 7. I'm going to keep doing that. And this plus this will give us 11, which is a sub 4. Now, technically, this is 5 terms. Occasionally, books will start out or text will start out with sub 0 as their first text.